in this lecture, we will read about the launch vehicles in India. The very first one to be discussed is the PSLV, that is a Polar Satellite Launch Vehicle. Now, the PSLV is a workhorse launch vehicle of ISRO since 1994. It was first operational launch of vehicle in India. More importantly, these PSLVs is basically used generally for the purpose of the remote sensing satellites. So that basically we can write the IRS. It is generally for the IRS, remote sensing satellites. And apart from that, they consist of mainly the 4 stages. So let me write it here that there are 4 stages associated with it. The very first stage is, let me write here, first, second, third and fourth. These are all stages. Now the first and the third stage are the solid fueled. So first solid fueled, right, and the third, whereas the second and the fourth stage are the liquid fueled. Here. More importantly, they also use sometimes the strap-on motors, which basically used in the first stage of the PSLV. So basically the strap stages are, for example, like if this is a rocket, so generally what happens, they provide an additional boosters here which are used to give the additional thrust to the rockets. So these are generally called the strap motors. So generally they also use in this thing. And generally the PSLV can deliver the payloads up to the 3 different times. For example, like they can provide a payload of 3250 kg to the LEO if we are sending using it to the LEO. It can also provide 1600 kg, 1600 kilograms to the SSO, which is basically the Sun Synchronous orbit, and 1400 kg to the geosynchronous transfer orbit. Yes. So these are the 3 different payloads which can be used for these things. Now it is important to note that the PSLV has quite a significance in India because the PSLV C337, so let me write it here, that PSLV C37 has recently launched 105 satellites, 104 satellites in 2017. So this is the highest number of the satellites launched in a single flight so far. No other country had did that. So this is a great achievement for us. So currently this is mainly about the PSLV that we need to know. Then the next is basically the GSLV. So GSLV stands for the Geosynchronous Satellite Launch Vehicle, and more importantly, the PSLV have 4 stages, but in the GSLV we have 3 stages. So it has 3 stages. The first stage, the second stage, and the third stage. So here, for the first stage, it is generally a solid fuel, whereas for the second stage, it is a liquid fuel, and for the third stage, we generally use a cryogenic engine. So this is mainly about the GSLV, and the important one GSLV that need to be remembered was a Gslv Mach 3. So that is Gslv Mk 3. So the MK is basically stand for the Mach. So this is what we also call as a fat boy. For the Gaganyaan mission, we will use this one. This is the heaviest and the most powerful rocket in India at present. It is a 3-stage using a cryogenic engine, 4 tons. It can transfer to the GTO, so that's important. Like 4 tons, that's huge, which basically around 10,000 kgs to the LEO itself. So we can write it here, the 4 kg to GTO and 10,000 kgs to LEO. So this is amazing actually. Even for the Chandrayaan 2 that we are designated launch, we will use a GSLV Mark 3. Even in the Gaganyaan that has to be launched in 2022, we'll use the GSLV Mark 3. Now, we are discussing these things. Let's also discuss about the cryogenic technology. So let me write it on another page. So, cryogenic. Now, the cryogenic technology, the indigenous cryogenic stage on the GSLV is a third stage. Actually, it uses two main components, which is basically called the liquid hydrogen as fuel and liquid oxygen as oxidizer. So these are the two essential things which cryogenic engine do have. So the cryogenic stage is highly efficient rocket stage that provide more thrust for every kilogram of propellant it burns as compared to the solid and the earth storable liquid propellant stages. More importantly, the cryogenic technology involves extremely low temperature. We can mention it here that it has using a very temperature is very low. So this when I do like this arrow, it means a low, right? And the hydrogen actually liquefies at extremely low temperature, for example like minus 253 degree Celsius. So you don't have to remember these things, just remember that it requires an extremely low temperature. Apart from that, nearly 50% of the power of the GSLV rocket as they push into space come from the cryogenic engine, and that's huge. And as a result, the engines operating with the cryogenic technology can lift the heavier satellites. So that is mainly about these things. And if we talk about the velocities, initial velocities of the PSLV and GSLVs, then I can say that if I write PSLV and the GSLV here, then the PSLV has an initial velocity, an injection velocity, what we call as 7.5 kilometer per second to put Earth observation satellite of nearly 1000 kgs. And in the contrast, the GSLV needs a velocity of 10 kilometer per second to take a satellite to the height of 36,000 kilometers. So these are just the facts that you don't need to remember, but I'm just telling you because they sometimes seems interesting to know about these things. So these are mainly about the GSLV and the PSLV. Now we have another one, which what we call as similarly. The third one is basically what we call as an SSLV. SSLV is SSLV. Now, SSLV stands for the Small Satellite Launch Vehicles. It actually, the ISRO has said to induct the SSLV in early 2020. And SSLVs are considered to be the small wonders capable of launching the payloads of 500 to 700 kgs in LEO, that is a low Earth orbit. So this is a one third of what the PSLV can carry. So it can reach up to the height of 500 kilometers in the LEO, and it will cost 1/10 of the PSLV, and basically and will need only 72 hours for the launch in comparison to the 45 days to the PSLV. So I think this is one of the good thing we can have. Apart from that, there is what we call a Vikas engine. We can talk about that also. Vikas engine. Now, like a cryogenic technology, we also have a Vikas engine. Now, the Vikas engine is generally used in the second stage of light lifting PSLV. So, if we write in points, so it is used in the second stage of the light lifting of the PSLV, and the second stage and the four add-on stages on the medium lift second, and the fourth stage of GSLV, and it can also be used as a twin engine core liquid stage of Mach 3. Mark 3 is the one that we have discussed, the fat boy. So apart from this, so this one seems important to me because the Vikas engine is completely an indigenous technology, and it was also used in the Mark 3, and the Mark 3 is important as for the Gaganyaan missions and the Chandrayaan 2. So they will use the Vikas engine in that for sure. So this is an important point. You can mark it here. Apart from that, the recently in 2018, the Vikas engine was improved for the higher thrust by 6%. So it enabled it to carry the 70 kg of the additional payload. Apart from that, the most important point is that it uses dimethylhydrazine dimethylhydrazine as a fuel and nitrogen tetraoxide as an oxidizer. So this is as a fuel and this as an oxidizer. So this is important point that you should keep in mind. So the next engine that we're going to discuss about is the LOx, the LOx Methane Engine. LOx Methane Engine. This was recently in the news, 2 months back. So the LOx is basically, first the Liquid Propulsion System Center of the ISRO is developing this thing. So the LOx methane, LOx is basically the LOx methane engine uses a methane as a fuel, obviously. So it uses methane as a fuel and the liquid oxygen as an oxidizer. So this is an oxidizer and this is a fuel. Now it has a multiple advantages. The very first advantage can be it can be synthesized in the space, because the methane can be synthesized using the water and the carbon dioxide, so we can synthesize the fuel in the space. Second thing, this is non-toxic, because when we have talked about the Vikas engine uses the dimethylhydrazine and the nitrogen tetroxide, which was actually much more toxic as compared to this one. And it has a higher specific impulse, it is easy to store, and it does not leave a residue upon combustion, and it is less bulky. So the LOx methane engines are pretty much good. Apart from that, there is another engine what we call as an ion rocket. These are not engines actually, these are pretty much what we call as a rockets. So generally we use them in the future because we have not developed it yet. So they will be used for the deep space exploration in future. So they will be used for the deep space exploration in future. So they are much more efficient than a conventional rocket, because the conventional rocket uses the chemical fuels, and the chemical fuels generate a velocity up to 2 to 3 km per second. But these ion rockets, they are capable of achieving the velocity of around 4,400 km per second, and that's let me write it here, 4,400, okay fine, I'm sorry, kilometer per second. And this basically take place with the help of electric repulsion. So the important point to be noted here is that they use electric repulsion of ions to propel rocket. So these is important. More importantly, the small scale ion propulsion is used in the number of missions, including the NASA Dawn mission has used this thing. Even the deep space mission, ESA, the European Space Agencies use the LISA Pathfinder, and even the Bepi Colombo and the Japan's Hayabusa mission. All of them use the ion rockets, and I think it's high time that India should also invest their money in using the ion rockets, which are much safer and much efficient. So in the next, we will discuss about more satellite systems of India. Thank you.